Hello, this is Mr. Stansbury. I'm going to take you through the notes on angles and angle bisectors, okay? At the end of this, you should be able to say, I can apply the angle addition postulate to find angle measures, and I can use the definition of angle bisector to find angle measures. Okay, so first thing, protractor postulate. For each angle, there's a number between 0 and 180 called the measure of the angle. Basically, this is just getting that you can take a protractor to any angle and say that it's 120 degrees. This one is 82 degrees, whatever. So that's the protractor postulate. Just saying that you basically can measure an angle. Okay. Next thing, angle addition postulate is if P is in the interior of angle RST, then the measure of angle RSP plus PST has to equal angle RST. So basically they're just saying if you take this angle here, if you take this angle here and you add that angle there, it equals this whole angle there. So like for example, let's say this was 31 degrees and let's say this is 22 degrees. Then that means that angle RST would be 31, let's do that over here, 31 plus 22 would be 53 degrees would be RST. Okay? All right. Next thing, bisector of an angle. That is a ray that divides an angle into two congruent angles. So it cuts it exactly in half. So we have angle ABC and BD here separates into ABD and DBC, where both ABD and DBC are both the same, which in this case is 23 degrees. So it cuts it exactly in half. Bisect. Bisect means to cut something exactly in half. Since it's an angle, that's cutting the angle exactly in half. Okay. Vertical angles. Opposite angles in two intersecting lines here are what we call vertical angles. So like angle 1 and angle 3 are vertical angles, angle 4 and angle 2 are vertical angles, and vertical angles actually have the exact same measure. Okay. The way that you could tell that is, that angle 1 and angle 2, since this is a straight line, these would be supplementary. And then angle 3 and angle 2 are also supplementary. So that would mean that angle 1 and angle 2 would have to be the exact same measure. Okay, because 2 is obviously going to be the same as itself. Anyway, that'll be a proof that we'll probably take a look at later on. Okay, one last thing as far as the notes. This upside down capital T thing is the symbol for perpendicular, which means, right at a right angle. Okay? All right. Let's take a look at some examples. All right. First example, use the angle addition postulate and the given information to complete the statements. Okay? If T is in the interior of angle ABC, measure of blah, 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 here's what I would do on these. I'm going to draw a picture. Okay, T is in the interior of ABC. So let's draw angle ABC first. Okay, so let's say that's A, B, C, and now they're saying P is in the interior of that, so we'll call that P. Okay, and it says measure of ABP is 50 degrees. Okay, and we know that the angle of PBC is 35 degrees. Now they're asking what's the measure of angle ABC. So the angle addition postulate says, all we got to do is just add those two together. 50 plus 35 is 85 degrees. Okay? Now, as we go through and we sketch these, it's fine that these are not to scale because we didn't even know ahead of time. So we're just going to draw something out just so that we can see what's going on, make it a little bit easier for ourselves to understand. Okay? B, if C is in the interior of STU, so again, let's draw ourselves stew here. So here's S, T, U, and then it says C is right in the middle of that there. So that's C. Measure of STP, C's in the interior. I did, this was supposed to be a P, sorry. P is in the interior of STU, so this is a P instead of a C. Then STP is 40 degrees. And then it says STU, the entire thing here, is 110. So that there is 110 degrees. They're going to ask us what is PTU. They're trying to figure out what this is right here. So if we know if the whole thing is 110 degrees, STU, and 40 of that has been used for STP, if we subtract that 40 there, that leaves us with 70 degrees for PTU. This part right here should be 70 degrees. Okay? All right, and then the last one on this example, if R is in the interior of angle JKL, so again, let's draw that thing. All right, so we've got JKL, and again, it's super important that vertex, vertex, vertex. Oops, all these are B's up here. B is the vertex. So K is the vertex of this angle here. So we got angle JKL. So we've got R is in the interior. So let's put R out here. And then we'll draw ourselves a line that goes through that. It says the measure of angle JKL, this entire thing here, is 4x minus 2. And then we know the measure of angle JKR, this right here, is x plus 2. Then they're going to ask us what is the measure of RKL. So we know that if we take RKL, what JKR, which is x plus 2, and we add RKL, which we don't know right now, it's going to equal this 4x minus 2. Okay, so what do we have to add to x to get to 4x? That's going to have to be 3x. And what do we have to do to 2 to get to negative 2? Well, first we have to subtract 2 to get to 0. We have to subtract 2 more to get to negative 2, so that's going to be minus 4. So this 3x minus 4 is what angle RKL is going to be. 3x minus 4. Okay? Because x plus 3x is 4x. 2 minus 4 is negative 2, and that's what that whole angle is supposed to equal. Okay, let's take a look at some more examples here. Given ray EM bisects angle DEF. So let's draw ourselves a picture, make our life easy. Okay, so we got angle DEF, and then it says E to M is, E to M bisects this angle DEF. So we know that this angle is the same as this angle, and that's one way of showing things that are angles that are the same. They have little arcs. We could also put a little double arc. So these double arcs are equal to each other. Okay, so it says find the missing measure. Let's see if the measure of angle DEF is 88 degrees. So if this whole thing is 88 degrees and this thing cut it exactly in half, measure of MEF, this right here, is going to equal what? So if the whole thing is 88 and it got cut exactly in half, we just divide by 2, and we know that each one of these pieces would be 44 degrees on this part A. Okay? If DEM equals 52, so if this is 52 up here, measure of angle DEF would be what? So that's going to be, this is also going to be then 52. So we'd have to add those two together. 52 plus 52, 104 degrees would be DEF. Okay? And then part C, measure of angle DEF is 2x plus 6. So DEF, this whole thing here, I'm going to redraw it just so we can Try that again. So we got this whole thing is 2x plus 6. Measure of angle DEM is going to be this thing here that cuts it exactly in half, right? So that means we just have to take 2x plus 6 and divide that whole thing by 2. So we're going to divide each piece by 2. 2x over 2. How about let's write this. 2x over 2 plus 6 over 2. And then we just simplify. 2x over 2 is x. 6 divided by 2 is 3. So then we know that that's going to be x plus 3. Okay. One last quick example. Find the measure of angle 3 if we know that the measure of angle 1 is 3x plus 7. Measure of angle 2 is 4x minus 2. Figure out what this is here. Okay, so we know that if we can figure out what angle 1 is, that's the exact same thing as angle 3. So let's see if we can figure out what these are. We know that if we add these two angles together, look, it makes a straight angle, which means it has to be supplementary, which means it's 180 degrees, right? So we know that 3x plus 7 plus 4x minus 2 has to equal 180 degrees. So now we're just going to use good old algebra to figure this out. So let's see, nothing to really simplify. We're just going to collect like terms. So 3x plus 4x is 7x. 7 minus 2 is plus 5 equals 180. Subtract 5 from both sides, right? And we have 7x left over here. And 180 minus 5 is 175. If we divide that by 7, we'll get that x is 25. Okay, so if we want to know what angle 3 is, we're just going to want to plug in our 25 in for this x right here, right? So 3 times 25 plus 7. 3 times 25 is 75 plus 7 gives us 82 degrees, and that's going to be angle 1 and also angle 3 because those are vertical angles. They're exactly the same. Okay? All right, that's all there is here for 4.2. If you have any further questions, please feel free to ask in class. Thanks.